so let me see. I'm going to start, guys, by the first thing. Very quick. I will go over the schedule. Do you guys have the schedule, colored schedule like this one here? Grab it. I'm going to let Mishad Cooley go over this one. I'm just going to very, very quick cruise you through this one because Mishad is coming in a second. They will go in details in that. Okay, here's what with the achievement, guys. You have week 1, week 2, all the way. It's front and back. Everybody knows it's front and back all the way to week 12, or actually week 11. We do have a presentation set at March 23rd, the last thing. Can you guys see that? What I would bring to attention, guys, is every week we will have a speaker and or a field trip. Did you guys see that? If you look at them, and I'm gonna let Mishad goes through them. A speaker or a field trip. Today, guys, you see week 1. Our goal today is to do Syllabi E1 through E14 this week. We lost one day. And we're going to be working on load calculation and project schedule. Load calculation and project schedule. So these are our goal to do this week. But we lost one day, so we might have to modify. Mishad is coming to introduce a project, and then if you can see, we're going to have a speaker and or a field trip every week. So Derek, there will be a lot of interruption in the project. So I'm not going to go over it in details, guys. I'm just going to let Mishad go over this. So with this, I'm going to go, let me go over syllabus. Okay, do me a favor, not this one, Chad. Let me go over this one, I believe. Okay, so if you guys go grab, I give you 2 handouts, right? One handout is for the project that has the colored paper in it, okay? The second handout is the syllabi. The syllabi for 3 classes that we're going to have. Like I said, Karen, we're going to have 5 classes with me this semester. The 2 classes are going to be in the last 7 weeks of the semester, so I did not give you information about the estimating project. Did you guys hear me? Because we're just going to focus on the first project. We close in 11 weeks, we final, we present, and when we move into the second 7 weeks of estimating. Everybody understand what you have right now is only 3 classes until 11 weeks from now. Then we close it and we open 2 more classes about estimating. Cool? Everybody understand that one? Okay, the syllabi. This is the industrial design theory, guys. What this is supposed to give you, if you look at this, here's the information. We're going to be running it from 7:30 to 8:25. So that's the class. It's going to be running, Karen, from January 6th, which is yesterday. Thanks to the temperature, we were not here. All the way into March 27. That will give you 11, almost 10 weeks and 4 days exactly to run this project. We're running it Monday through Friday. Can you guys see that? This should be the second handout. The second handout, and you guys go to write the second syllabi in the package that I gave you. The second syllabi in the package that I gave you, right in here. There are 3 syllabi, the second one. Okay. This is just information about when to start, where we are. My office, guys, is Blue 19, but I'm typically here if you need any help like we have done in the past. They're not new. All the information about the course, Karen, has been set on My Dunwoody. So the tests and the quizzes, and we don't have quizzes, the tests and the homework and what's not have been set on My Dunwoody. You will see it. It's always public. The name of the class, guys, that you're paying good money for is called Electrical Industrial Design Theory. What we do for this one, I walk you guys through the code and the wiring methods for an industrial project using rigid. We're going to be using rigid PVC schedule 80, and we're going to use also rigid metal conduits and wiring methods for a factory. That's really what this project is. So we walk you through the code requirement for hazardous location, major part about the hazardous location. So theory of wiring and designing a project for an industrial, a project for an industrial building. It's a 3 credits, guys, 54 contact hours. We talked about the prerequisite here. You already done the prerequisite, all of you. Textbooks, We're using Herman Electrical Wiring Industrial Edition 14. It looks like $75 here. It's different than what I told you. So I don't know. I think it's around that number. Um, National Electric Code 2011 will continue to use it, guys, because it's in Minnesota until July 1st. That's when we switch to 2014. So we're not going to switch here. Um, this talks about the core abilities, applying math and science and what you guys are paying for to come to Dunwoody and communicate effectively, demonstrate civic and global environmental and cultural responsibilities. Obviously, that's not my goal to teach you that one, but that's the core ability attached to you being a Dunwoody, global citizen and what's not. You guys read through this. Outcomes. That's what we teach you in the technical, mainly our focus is cite the National Electric Code for electrical project, design electrical system for buildings, manage electrical construction and engineering projects. That's the goal. What you guys will learn in this project, and I'm waiting for somebody to come back and say, Chad, you have not taught us this yet. I always share them here. Nobody ever challenged me. Not like you can't, but probably explain. Here's what you're gonna be learning, guys. Explain service entrance conductors, feeders, and branch circuit for industrial buildings. What I always tell the people when they come to us, guys, this is the same competencies that we did, almost the same that we did for a commercial project. You know what we did? We modified them slightly for the industrial era. That's all. We just modify them because industrial building have harsh environment, hazardous location, bigger buildings, bigger load, and you need to design a system slightly to match that environment. So we still talk about service feeders and branch circuits and how to size them. Then we move into ATS. Remember the ATS? Who presented the ATS? Was it you, Matt? We'll still talk about this. UPS and PDUs, panel boards, switchgear, switchboards. We go over these. What do they for a living? How are they building blocks in the electrical power system that you guys are going to design? Um, Explain conductor and cables and conduits and bus ducts and duct banks. So we will have bus ducts, guys, and we will have duct bank underground to bring all these. The project that you guys are going to design, it's a 4,000 amp building, 4,000 amp, 480, 277 building. That's what the size is. Yes, sir.
Are we going to be doing like the light on that? Are we going to actually want to like make sure we actually meet the energy codes then this time?
Yes. Everything that we did for the commercial project, we'll do for the industrial project.
Well, are we actually this time?
Yes.
Okay.
We're trying to meet it. Yes. You know why? Because we're using LEDs.
Okay.
I don't think we flipped the switch on that thing. You might. I think it's not plugged in. Is it on? Okay. Yeah. So yes, but we're using all LEDs. You're going to see the fixture, so you can easy to meet it. Um, Lighting systems, we'll talk about lighting systems, security system, fire alarm system, paging system, phone data system, master clock system. All these systems, guys, are going to be in the project. We'll talk about how to work and size them and what's not. And adhere to the NDC code book requirements is a big deal. Um, Grounding and bonding, I will focus a lot, guys, on grounding and bonding. This project, you'll see a lot of grounding and bonding. Lightning protection, lightning, not lighting. Lightning protection, we have a whole chapter about lightning protection. Overcurrent protection devices for buildings. Um, the same thing, guys, emergency standby power, emergency legally and option standby power. We talked about these in the commercial project. We will continue to talk about them, guys, in the industrial. I hope, Matt, you understand. What you guys are doing right now is not brand new knowledge. It's building on what you have done and expanding on it. Does that make sense? And repeating some of the materials. So one more time, hopefully by the time you graduate, guys, from here, it sticks. Because do you guys agree with me that I threw tons of stuff at you on the commercial project? There was a lot of stuff. Now you're going to hear the same terms and expand on it. Analyze commercial building plans and specifications. PLCs, we'll talk a little bit about the PLCs. We're not PLC experts, and fiber optics for communication. Hazardous location, major topic, guys, in the commercial buildings. We'll talk about hazardous location. And we'll talk about the effect of harmonics in designing a power system. That's all these, Adam, are chapters in this book. So you can see the reason why I like this book. It's simple, easy. It follow each one of these chapters. I believe it gives you what we intended to give you in this 11 weeks. Remember, always think of it 11 weeks. Okay. Um, Instructor grading. How we grade you guys, exactly like we did. I don't like to switch gears, Karen. So what we have done with the commercial project, guys, we will do in this. We will have 4 tests, 12.5% of your final grade. Classroom engagement is 10. Classroom engagement is if you're paying your attention to your friend chat like you guys have done, engage with the industry and what's not. And homework, the homework is the honor system. I don't correct the homeworks. I collect the homeworks and give you grade, guys. I go over the important stuff for the test. So please, the homework is just to prove that you read the chat. That's to me what the homework is. Easy to get 10 points. And we have a final exam 30 for a total of 100%. That's your assessment with your friend Chad in this particular project. Any question, guys, about that? Extra credit, like I always, if anybody gets less than a C, I always give you guys an extra credit or something to get at least a C. So I don't like to give less than a C. That's my philosophy. Here's where you get your A's, Adam. If you get 95 or higher, get your A's, and then 94.99 to 90, get your A minus, and all the way through. So you guys read it on your own. I don't like to look at the D's and the C's, C minuses. I like to at least give you guys a C. Um, okay. Academic honesty, if you want to cheat, just talk to me. Don't worry about it. There's nothing really to cheat about. We're interested, guys. Adam, I'm interested in you guys finding you're already working. Doing a great job with what you're doing, not in harassing you and punishing you with tests, right? You probably have noticed that. That's about me. Not too much into. You don't have to cheat or do any of these. Plagiarism, there's nothing to plagiarize. I give you guys the project right in front of you. You're going to see it. Ask me about it. Here's what the students have done in the past. Now go ahead and do it and do better than that, right? That's how we're application people. We're interested in the process working than reinventing the wheel. Um, Add drop. Anybody wants to add and drop? There's still a week to add and drop. I don't know if you guys want to add and drop. Disability. I don't see any physical disability. Mental disability, Derek, I don't know if we can dig into that one. But if you have any disabilities that are unseenable, let me know. Incomplete. I don't like to give an incomplete, guys, and you've been really good in stepping up to the plates last semester, and I have no doubt that you can do the same thing this semester. Intellectual property statement, not a whole lot that you can. We're not writing research here. Respectful environment to students and behavior. Thank you guys for being great last semester. So I think we're gonna have a great spring semester. We really do. Um, Academic assistance. If you need, I stay here, guys, until 12:30. Karen probably adhere to that one. She leaves when I'm here at most of the time at 12 until 2:30. So if you need any help, stick around. We have very small groups, so you guys, the lucky ones. So you have my full undivided attention. Talk about appropriate behavior. Here's what I like: classroom engagement. We did them in the commercial project, guys. Cooperate with and helping other students. I really appreciate it when Derek is stuck with something. If Karen or Matt or Adam, guys, any one of you, help them. Here's how we do it. Here's how I've done it. I'm here also to help, but you might be stuck with something. Participate in the classroom discussion with speakers. Very important, guys. We're gonna have at least 2 speaker slash field trips every single week. So it's gonna be busy here. Research new classroom materials and share with the students is a big deal. Share environmental lead and employment leads. So if Shad Cool is hiring Adam and you come to us and you tell us that they're hiring one of the students get hired, I'll give you credit for that too. Attending NCL evening meetings is also great networking opportunities. Attendance is a big deal, guys. So please, we have 7 weeks, 11 weeks, a lot of stuff to do in 11 weeks. So please utilize your time wisely from the get-go. Otherwise, you're going to find it will sneak on you, Derek, and you're going to see that you're behind. Positive attitude in the classroom. I didn't see any any negative attitudes. Computer shutdown. I used to make the students shut down their computer while I'm lecturing. I changed my mind over that. Neat, clean, and organized desk and basket. You guys look at your desk after you left. You took your stuff. I cleaned it. I expect it to be like this. All times you have your baskets here. There's extra baskets if you need. Adam, if you need another basket for you right there in that corner, you put your stuff in it. We have a smaller. So get yourself organized, guys. You're engineers and designers, so you are above average. Um, so attendance, you guys are supposed to attend 95% of the classes. I haven't been, in the winter when it snows and so forth. I fully understand, waited for you, but please be aware that you are, based on our policy, to attend 95% of the classes. Okay, here's the schedule. This is probably the most important thing in the syllabi is classroom schedule. You can look week 1 all the way to week 11. We're going to average, Karen, 2 chapters in this book a week. So if you want to plan your homework, Adam, and what's not, we're going to do 2 chapters a week. So we're going to start with the introduction. We're doing it this week. We're going to cover chapter 1 and chapter 2 this week all the way, guys, into week 11 when we're going to have our final. We will have our tests. I don't know if you guys can see right here. It tells you which week is going to be a test. Like we have a test number 1 in week 4 and week 4, and in week 6, we're going to test number 2. Number 3 is going to be test week 8. And we're going to have week 10. We're going to have test number 4. And final is going to be in week 11. Yes, sir.
So we're just done with that lighting book then?
We're done. Oh, that lighting book that we did in the commercial?
Yeah.
Yes, we're done. We're done with it. Yep, we're done. Any comments, guys? Any questions about the schedule for this class? Okay, so that's basically what you guys are paying an arm and a leg for. Is it worth it? Oops. If you have other opinions, please plead the fifth. All right, so this is, I'm gonna go to the second syllabi that we guys have. Um, okay, so, okay, here you go. Can you guys go to 2230? 2230. I'm gonna grab some of my coffee here. Uh, Anybody wants coffee? Nobody drinks coffee other than Matt and I?
I just finished my cup, so too much of that.
Too much, you get too hyper.
Yeah.
Okay. Well, here's the second syllabi. Now, I want to remind you guys, you're taking 3 classes with Chad. Everybody understand? One of them is calc, 1 theory, and 1 project, right? We did the theory, and they're all entwined. They're not standalone. It's not like you have noticed that math. It's not like you're taking biology, and the other one is physics. They're all like kind of physics, but different aspects of physics. That's what we're doing. They're all electrical design. We do the theory, so we know how it works. The theory book will tell you how things works and how do you apply the NEC book. Then this is purely related to calculation. How do you do calculation for industrial project? Every aspect from the bus ducts into the generator into this transformer, tons of calculation. Same information, guys. We started yesterday. We should have started yesterday. We're starting today. And it goes until March 27. That's when we finish this class, gentlemen. Monday through Friday. It starts at 8:30 to 9:25. We are here in Red 7. All the information about this is on the network. I don't know if I told you, Karen, everything that you guys have done, all these syllabi, I always give you a hard copy and also an electronic copy in the folder, the instructor folder online. Everybody understand? There's also an electronic copy in the folder. Okay, electrical design calculation. So what we're going to be doing, guys, in this project is we're going to take all the aspects and do the calculation to size it, from PDUs, power distribution units, ATS, generators, bus ducts, transformers, and we do a couple of worksheets about each and every one of these aspects. That's what we're doing. Why do we do it this way? Because these are the building blocks of a power distribution system in a commercial industrial building. So you need to know how it works first. We use this book for it and the code. And how do you size it and design it? We use the calculation. Cool? See how they're related? So in one, we'll be talking in this theory book, guys, about the bus stocks. And what's the bus stocks? How do you size it? What's the, not how do you size it? What's the requirement for the code for it and how to install it, right? And then we go to the calculation and say, well, here's this load, go size a bus stock for it. Do you see how they're related? And then we go to the project and we say, well, in your project, you are required to have two bus stocks, one 208, 120, the other one is 480, 277. Here's a manufacturer floor, go size, this, actually lay out your bus stock. And you're going to see how beautiful that is when you put it in Revit. Really cool. 3 credits, gentlemen, you're paying 454 contact hours. Um, the same thing, we're using the electrical wiring industrial and the national electric code, guys, as a reference. I used to use other books, but it's we got away. The same core abilities. In terms of the competencies, you can read them, guys. There's almost 15 competencies. It's all about calculating the services, the feeders, and the branch circuits, sizing them. Then we use sizing the ATS, the UPS, and the PDUs. Then you're going to do an electrical load calculation for the commercial building. Then we'll do size of security system, fire alarm system, sizing the conductors and the cables. Not a whole lot of calculation. Paging system, sizing for the phone and data system. Master clock system, laying out these fixtures. Grounding and bonding, tons of calculation about this. Lightning protection is just how it works. We talk about these. Overcome protection devices for every single panel. We'll talk about this one too. And perform motor, all these motor, transformer, generator, capacitor calculation. Select lighting and luminaires. We did a whole class, guys, about lighting last semester, so we'll still touch on it. How to select the lighting and luminaire in the fixture. So if I am to summarize this class, it's the word is calculation and sizing. Generators, transformers, UPS, lighting panel, receptacle panels, all these, how to size them, and sheet step by step how to perform these calculations. Any comments, any questions, guys, about the competencies? Any comments, any question? Competencies are the skills. So when you go to an employer and say, what the heck did Dunwoody teach you? If you want something to summarize it, here's their competencies. They call them competencies. Okay. Instructor, the grading, can you guys see it's identical to what we have done in the theory? Exactly identical. 4 tests, 1 homework, and 1 homework, as well as classroom engagement. I can't emphasize the classroom engagement. And final test, identical. Scale is identical. You know, there are 2 classes. Their focus is different, but we run them exactly the same. Everything else, guys, is identical all the way into the schedule. Schedule at the bottom. This is what I'm going to be introducing to you guys in this project. If you look at for example, week 1, which is this week, it's on the board right there. Can you see it there? We're going to have Article 450. We'll talk about Article 450 in terms of sizing transformers. We're going to go back and size transformers for lighting panels. Then we're going to talk about generator sizing, sizing feeders for generators, and we're going to talk about busways 368. These are the numbers that you can see, guys, right in here. These numbers are NEC code articles. Everybody understand they're NEC code articles. That's what we're going to do this week. Next week, we're going to continue talking about panel boards and capacitors and motors. Then week 3, we'll be talking about generators and busways. And you can see certain things repeat itself because we look at it from a different angle, as you can see. And here's the homework, guys. I have homework 1, homework 2. Then we're going to have test 1, homework 3 and 4, test 2, homework 5 and 6, test 3, homework 7. And then we're going to have test 4. So all these are the equipment, PDUs, UPSs, HVAC equipment, grounding and bonding. All these are the topics that we're going to do. And then we're going to get our final in each and every one of these topics that we covered. All these are the articles that we're going to be tested on.
Where's the homework?
Yeah, I usually write it on the board. Remember how we did the calculation at the end? So we'll take, for example, sizing a transformer for a panel, a lighting panel. I go through the calculation at the end. I put the homework at the end of it. Yeah. Any comments, guys? Any questions? So these are the topics that I selected for you to do the calculation about. Like you said, Adam, there's no lighting. The lighting book is gone now. So we're doing all. Oh yeah, visual. Yeah, visual is a whole different story. Visual is for the project. We'll continue to use visual and generator sizing and everything that we have used in the commercial project. We'll be using it. But we're not going to do point-to-point calculation lighting like we've done. Done. You guys are you're on your own now. Any comments, guys? Any questions about that? Comments, questions? Let me do over this last syllabi before Mashad shows up. Okay, can you guys go to which this is the first page. I leave it. That's the first page of the syllabi that I gave you. That's a project. That's what people hire you for, guys, because you can design a project. Everything, all the theory and the calc Adam, is meaningless unless you take all this knowledge and dump it into an E1 through E14 and make a project out of it, right? Who cares if you know how to size a generator unless you put it in a project, right? Sit there and do all the math calculation. That's called mental exercise. What makes it valuable is when you take this knowledge, put it in Revit or CAD, have a blueprint, sell to the customers, they pay you for that. Right? Nobody pay you for just doing the calculation. Everything that we calculate in theory and all this stuff, that's just to help you design a project. Everybody understand why are we here? Design a project. Our job is designing a project. Okay, so for the project, guys, here's my oil industrial project. This is going to run from this project from 9:30 after our two lectures all the way to 12:30. Again, January 6th, yesterday through March 27, Monday through Friday. So what is this project? This is a really cool project, guys. It's a two-story building. In one side, on the other side, it's an open manufacturing floor. So imagine one section of the building, two-story, right attached to it is another section that goes to the height of the two-story open manufacturing floor. What does it do for living? It's supposed to be a medical plant modeled after Boston Scientific, which you guys will be touring next week. We did a tour, so you're going to be touring the building that this project is modeled after next week, early on, so you can see how the system is set together. So instead of doing it at the end like we did the commercial project, over the feedback from the students, they were saying, well, it would be great if I just saw the bus stock before I start designing it. You have a chance to go see the whole system before you start even designing it next week. Cool. It's a 25,000 square foot building. Like I said, two-story building, offices, and labs and what's not here. The other half section of it is a big manufacturing, open area manufacturing floor to the height of the two-story building. What your job, guys, is to do is you need to design it using Revit, layout of lighting, power, and low voltage. Exactly like we did the commercial project for the two-story side as well as for the manufacturing side. In addition to what we did in lighting in the commercial project, Karen, we have bus ducts now. We have bus ducts, we have underground ducts, we have PDUs, we have hazardous location, and we have a data center. We haven't done that. So in addition to what you guys have done, there are other special occupancies, special places that we need more attention. So for this one, guys, we're still using the electrical wiring industrial as our reference and what's not. Here's the learning supplies. We will be using Microsoft Excel and PowerPoint for the presentation and Excel for your load calculation. Drafting, we're using Revit MEP 2013, guys. Power design and analysis, we will be using PTW. Did you do the PTW? Okay, Matt did the PTW. We're going to expand on the PTW and do it for the whole project. You guys know a little bit about it. Now we're going to do it a little bit more. Visual, Adam, we just talked about visual. Here's your visual. It's there. How about ComCheck? We will be doing ComCheck. Are these familiar names to you now, by now? I hope so. We just finished a project with it. And then we're going to use Common Suite software. That's for the generator sizing. So that's basically the softwares that we're going to be using. Core ability are the same, guys. Competencies. The competencies basically very similar. You can see there's in details. There's how many of them? 34 of them. But summarize it with the following: you're gonna design and lay out and circuit and tag the lighting, the power and the low voltage for this building. That's it, using Revit. Then we're going to do load calculation, guys, sizing all the panels in this building, like you have done. We're going to do also lighting calculations, like you have done. Com check, energy code calculation, generator sizing. This building will be backed up by 100% generators. So you're going to have, literally, you're going to have a big boy sitting outside backing up the whole building. Um, we're going to use a parallel switch gear. So every aspect that we're going to be using, guys, is right in here. Laying out, you can see layout, lighting, power, security, fire alarm. That's in Revit. You know how we lay them out. Then we circuit, then we tag. Do you guys remember that? Layout, place them, circuit them, tag them, exactly what we've done in Revit. No difference. The only difference is we have different families, bigger project. Um, and the complicated one in Revit, I have to admit, is because we have two-story building. You're going to be working in the second story. In the first commercial project, guys, we only have one story. So you drop a receptacle, it only shows in the first floor because there is no second floor. When you drop a receptacle in a two-story building, if you don't put it at the right height, guess where it sits? You might see in the second floor, but it also will show on the first floor as well. So that's because the area that has two-story needs a little bit of attention. That you might drop something. See, I didn't drop anything, Chad, in the first floor, but it's still showing. Remember, you put it in the second floor at the wrong height. It went all the way down to the first floor. Okay? That's a two-story building. Create a little bit of, if you pay attention to the beginning, the height, very important to pay to the height. Because if you don't put it at the right height, it goes in the first floor, right? In Revit. So that's basically all the competencies that we're going to be using, guys. I'm not going to go read each and every one of them. Um, any comments about these competencies? So if anybody asks you what did you do for Dunwoody, and they, their hazardous location, we'll talk about hazardous location, guys, a little bit in details and what do you need to size for hazardous location. Did you guys see the major explosion between in North Dakota? Do you see that? That's what a hazardous location is. Anybody saw that one? That big, it's like a nuclear bomb exploded. Do you see the mushroom went all the way up? Unreal. That's when you have any highly flammable material, guys, in any area. And you have electrical right next to it. Electrical will give it what? The spike. You give it a spike to a natural gas tank or gasoline, or what do you get? Major explosion. That's called hazardous location. So we pay attention to how do you design a system for that, so you don't end up with a major explosion. Okay, assignments. Here's what the you guys. So please, every week when I ask you for certain things, please get it done, print it, put it in the back. And this time, unlike the first week where I wasn't able to go in details with you guys, we'll sit in the back and we'll go over every single assignment. But please give it ready for me so I have something to go over. I will give you 5 points for assignment in time. Cut sheets, 5 points. Does that sound familiar? That's how we do the project. All your Revit, Karen, is only 40% of the project. Just FYI. And generator sizing 5, lighting calculation 5, load calculation 10, energy code 5, power analysis, SKM 5, project schedule 5, specification 5, and project binder, put a nice project binder, get 5 out of 100% of you. Just have a nice looking binder to present. And presentation is 5%. That will add to a total of 100% your grade in this project. Does that make sense? All this is the same, guys. Academic honesty and what's not. The schedule, this is the schedule in the back, is the same, should be the same as the schedule that you guys have, that I give you at the beginning. So you don't have to worry too much about it. It's just I put it in the Syllabi. Any comments, guys? Any questions? Any comments? Any questions? So that's your project with your friend Chad. So we got the course syllabi here. Do not save. Okay, so we got what design build. Okay, now do me a favor. Go to the second document, this document that has the schedule, and let's talk a little bit about the project. A little bit. You guys need. Mishad is going to be here at 9, so I'm going to go for another 15 minutes and give you a break. before Michelle comes. Is that okay? And I'll let them go through the scope. No more than 15 minutes. So, the schedule, Michelle will go over it, guys, like we said. Go to the second page. Everybody can see the second page here. That's called 2210. I want to remind you, everything that you see in your hand, you're holding in your hand, Karen, is also online under the instructor folder. Everybody understand that? So you have a nice copy for your binder later on. Okay, it's a design build project requirement. Industrial project, here's what you need to do. You need to do a project schedule using Microsoft. You guys remember what we done? So here's, if I were you, here's what I would do, guys. I would go to my commercial project, Adam, copy it, name it industrial, modify it. That will cut at least your time by half. Because most of the stuff is the same, except it needs a little bit of modification. That's what I would do with most of this stuff. Load calculation using Excel. What I do, because the load calculation gets complicated for a 4000 amp switchgear, I have a template that I give you as a PDF file, and you go build that template in Excel. Otherwise, you cannot do it. It's just too complicated. With the NEC code book requirement, that template will size every single panel for this project, not just the switch gear, not just the main panel, every single panel. Neutral and phase. Revit MEP, guys, that's for E1 through E14. Minnesota Energy Code, we're going to do COM check. Lighting calculation using visual software. Power system analysis using PTW. Generator sizing comment. Specification is just given to you. Microsoft. Cut sheets, you will do cut sheets about the power, like exactly like we did for a commercial project. Only power and lights, lighting fixtures. Project presentation, you guys have done that, so nothing new. Design, everything that you have done has to be on the network. We have a folder, it's already set for you. I'll show you in a second. And project binder of the items mentioned. You have to have a project binder. So that's just stating what you guys know. Requirement. The requirement will be the NEC code book and the scope, guys, that Mishad Cooley is giving us, which is part of the package you're going to see at the end here. Project schedule. We're going to be using, it talks about how, I'm not going to go in details now, but it talks about the people. We're going to have 9 electricians, basically, 3 electricians and 6 apprentices. And that's how much we're going to pay them. That will be great when we do the estimation later on. Okay, this is what we're going to be doing, Karen, this week. We're going to set up these sheets. Can you guys see that? So sheet 1 all the way to sheet 14. Sheet 1, the bolded stuff, Adam, is what the sheet title is going to be. So title sheet to include list of the electrical sheets. Don't try to include on the name. Symbols, power riser, low voltage riser, site plan lighting and power, first floor plan lighting, second floor plan lighting, first floor plan power and second floor power, first floor low voltage, second floor low voltage, lightning is sheet 11, lightning. Please pay attention to the lightning, not lighting, that lightning protection on the roof. Panel schedule, equipment schedule, and lighting schedule, and details. Does that sound familiar to what we have done in the commercial project? Expanded. That's it. The idea, guys, is to hit 2 projects similar with slightly enough differences to make it valuable for you to practice again. Okay, so that's we're going to be starting tomorrow. We'll start doing the setup in Revit step by step like we did with a commercial project. Okay, Revit drawing setup. We're going to do it tomorrow, guys. I have families for you to use. We have a title block and what's not. All these we'll start doing it tomorrow. Families will be given to you. Minnesota Energy Code. I want to, like, if you look at item number 7, it says see item number 13. It will tell you what you need to do calculation, guys. Minnesota Energy Code calculation. Service calculation. See item number 13. You need 10% future growth and 15% growth on the panels. Cut sheets, what you need to do, cut sheets, project presentation, project submission, and all the way to binders, Karen. When you did your binder, here's the tab. I would like you guys to do the tab. If you're emotional about changing the tabs, just change it, put them any way, shape, or form. But that's one way of doing it. Logical way of doing it. All from the narrative to schedule to all the Revit to the calculation load, lighting, Minnesota Energy, generator sizing, power analysis, specification, cut sheets, PowerPoint. Then project binder tabs. Here's a little bit details on it, guys. If you look at the load calculation, here's, you need to do 9 load calculations in one sheet. Can you guys see that? Using Excel. For the main switchgear, receptacle, lighting panel, mechanical 1 and mechanical 2, and bus duct 480, 208, PDUs, and emergency panel. Energy code, we're going to use interior and exterior, like we done the commercial project. Power system analysis, here's what we're going to do, and you print from it. Generator sizing, same thing. Load report and generator size. These are what you need to print and do. Cut sheets, here's all the cut sheets that you need to do. Visual lighting calculation, all the stuff that you need from visual. Gentlemen, and you only need how much time you have? 11 weeks to finish this project. Any comments, guys? Any questions? Any comments? Any questions? So that's basically what we're going to be doing. The last thing that I want to stop by and wait until Mishad probably come is scope. Can you guys see that scope? You have the 26 scope, 260001. So this one, Mishad is coming, like I said, today. They will walk you through this one. So let me just fly you quick through it, very quick, and they'll hopefully it'll go. Medical, it's a medical production manufacturing plant, modeled after Boston Scientific. This is their spec from Mishad. This is, I don't know if you guys can see, it's a 2-story building. It's 15, almost 16,000 square foot, the first floor, and the second floor is 8,000. So a total of close to 24,000 square foot building. All the assumptions are here. 1.2 code that you have to adhere to is 1.3. Can you guys see coded standards? Then you get into the design criteria. 15% growth. Can you guys see that in B? The system is 48277. Here's all the stuff that you need to do, and I'm going fast because I'm not going to steal the thunder from Mishad. And we'll go over these guys in detail. So that's your guide. We have design criteria for the emergency power. Here's the emergency power, 100% power. Here's your 1.6 atom as design criteria for power receptacles. Where do you need your receptacles, Chad? Here's where it tells you where exactly your receptacle is going to be lit up. Can you guys see that? In every area. Design criteria for power distribution tells you what they need to do for the bus duct and what's not. I'll leave that one. 1.8, design criteria for owner equipment, list of the owner equipment, design criteria for mechanical equipment. Here's all the mechanical equipment, lights. Derek, and I'm going fast over these guys. I'm going to go over in a second here. 1.10, can you guys see industrial? Do you see LED next to each and every one of them? Do you see an LED? We're going to be using a lot of LEDs here. That's why you meet the code is not a big deal. Lighting protection, lightning protection. We have paging system, fire alarm system, and technology system. And that's the spec. Very quick. We do have, let me see here. We do have security. It should be open. I don't know if I open that. Okay. I also add a security system for you guys. It should be at the end, right? If you look at there's one sheet, standalone sheet. They have security system. Can you guys see that? Come on, open. So that will tell you security systems. How do you need to do a little bit more information about the security system? Why is it not opening? Does it want to open today? Okay. While it's trying to open, guys, can you guys go to the last page of the package that I gave to you? Do you see that schedule here? I know you can't, you barely can see it, right? These are your mechanical equipment. These are your mechanical equipment that will be installed in this building. Can you guys see it? This one, there are two of them. One is the mechanical equipment. It's right here. Can you guys see that? That's your mechanical equipment. And the second one is the owner equipment. So the first one is mechanical equipment. The second one is the owner equipment. Let me show you the owner equipment. If you guys go to the back of your page, the last page, you see a schedule like this, a little schedule. And again, if they're too small and you can't see like Chad, don't worry. You guys have electronic access to all these on the network right now as we talk. So, two schedules. One owner equipment, one mechanical. So, Adam, what the heck is the difference between them? The mechanical equipment, guys, are the equipment needed to heat, cool, and ventilate the building. They call them mechanical equipment. So, air handling unit, chillers, rooftop units, what's not, pumps. That's your mechanical equipment. Heating, cooling, ventilation, the mechanical engineer's part. Now, what's the own equipment? Now, remember, this is a manufacturing floor. So what do you do in a manufacturing building? You make products. So these machines that make the product, what do we name them? They're not heating and cooling the building. They're making products. They call them owner equipment list. For example, I have tube mill. Can you guys see that? Um, Number one is called tube mill. I have 12 of them, 12 machines. Each one of them is 28120, three-phase, and each one of them will be sucking 13 amps out of the system.
So is this where it separates the both main or the mechanical panels? One's going to be the owner equipment, and one's going to be the air handling units and the oil pumps and all that?
No, the mechanical panels will be strictly for the mechanical equipment.
Okay.
These will be fed from not a panel, a bus bar.
Oh, okay.
So all the mechanical equipment, guys, we don't feed them from a panel. We grab a bus duct. Now, what the heck is a bus duct? A bus duct is, it looks like something like this, and you plug loads into it as you go. And we'll go over this one in details. We feed, all this equipment will be fed from a bus duct, coming from the top, cables coming out of it, feeding all these machines as you go. If you've ever been in the manufacturing floor, you see them all the time. Okay, so we have owner equipment. When I say owner equipment sizing, Adam, SO cords, you're going to go here. When I say mechanical equipment sizing, you're going to go to the mechanical equipment. We're going to have an owner equipment schedule and a mechanical schedule. So that's basically, guys, the information. Without stealing Mashad's thunder, I'm going to stop right here, and I'm going to get ready for Mashad by opening Revit and what's not. So any comments, any questions about what we have so far? Everybody knows what you guys have a package. I can't emphasize, everything you see in front of you is where? On the network as well. As long as we're talking about the network, let me just mention this one, will you please? If you guys go to, um, if you go into the network, you find, can you guys see, if you go, you find the instructor folder. Who was team one? Okay, if you go to the instructor folder, Adam, under instructor folder, you're going to find everything that we have done so far. Uh, Under Revit families, you're going to find here, it says industrial, Revit family industrial project. That's what you're going to be looking at for families. If you go to the, now residential, commercial, we're done with these. Here's my industrial, and here's my estimating to be. So if you go to industrial, and you go to the project, and you go to the scopes, here's all the files that I guys I was showing you. They're all in the network, the files that I showed you. Okay, now, if you guys go to your team folder, who's team one? Your team one. If you go to team one, you will see two new folders right now, right? We have finished residential commercial, so please go to industrial, spring, click on it. You're going to find, if you click on the design project, you're going to find a CAD, all the CAD stuff that we have here, guys, and you're also going to find Revit. Under Revit, you're going to have architectural, and you're going to have electrical. Now remember how we did, don't open anything, please. When you go there, guys, you're going to have the architectural, that's architectural central file. The electrical is your central file that link to the architectural. I already did the linking for you. The project is set, ready to go. So starting today or tomorrow, my plan is tomorrow, guys, to walk you right through the setup from the get-go. Just be aware everything is set up for you. And then if you go back, Adam, you can see the folder for cut sheet. So you put your cut sheet here, estimating stuff, you put it here, generator sizing. Estimating is not going to be, we're not going to do any of the estimating here. Generator sizing, lighting, load calculation, all these folders, you guys will be filling information into this folder. Specification and what's not. Does it look exactly, Derek, exactly like your commercial project? It meant to be. So seamless transition from one semester to another. So I want to bring to your attention, if you are team two, who's team two? Adam, you're going to go there. So we're done with the residential, commercial. We're going to go into the spring, industrial. When we're done with the industrial, guess what we're going to do? The spring estimation. Don't touch the estimation yet. We're not there. So that's everything is set up for you. Hold your horses, and until we start. So I'm gonna. Well, how about if we have 5 minutes or 10 minutes until Michelle guys comes? That will give me enough time to open Revit for them and get ready for it. Cool. Any question, Karen? Any questions? Any? Are you guys excited to get run? It's only 18 weeks for the two of them, the two projects. 11 weeks. We finish the project and we hit the estimation 7 more weeks and we're done. Then most of you will graduate. We will hold a new mat for another 18 weeks. All right, thank you guys.